It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear.
So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 202 of Science on Top. Today is Sunday, the 4th of October, 2015. I'm Ed Brown and joining me today, Dr. Shane Joseph.
G'day.
Penny Dumsday.
Hello.
Lucas Randall.
Hey.
And our favourite planetary scientist, Dr. Helen Maynard-Casely.
Hello, and happy Sputnik Day.
Is it Sputnik Day today, is it?
It's Sputnik Day.
This would be an anniversary then of its launch, its orbit,
Yep.
its something.
Yeah, its launch, I think it was in 1957 on the 4th of October. Man entered space, or humankind entered space.
Oh, so I can't blame it for losing an hour today.
No, sorry.
Right. Damn.
And what did they do when they got there? They went beep, 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 beep.
Thus heralding 40 years of incredible spaceflight, and then we stopped.
Yep.
Anyway, but speaking of space, Helen, there's been some big Mars news this week. I believe Matt Damon has found liquid water on Mars.
But then we left him there.
Disappointed. I waited up to 1 a.m. and they didn't start that press release with, "Hey, we found Mark Watney." Given how much NASA have paid into the PR of that film, it's just amazing, isn't it?
So we're talking about The Martian, which is now out in cinemas, and I believe you've been already to seen it, haven't you, Helen?
I have indeed. I saw it last Monday. Yes.
Do you think it's science fiction that respects science fact?
And that's what the headline of my article says.
You wrote a review of it in the conversation, and
I didn't write that headline. I actually, and if anyone goes to see it, they'll appreciate the geeky wittiness of this headline.
Okay. Well, I haven't seen it. I think Lucas has, but I haven't.
Okay. Oh, cool.
So no spoilers, please.
My actual title of my review was "One Does Not Simply Rescue Someone from Mars."
Wait, that's a different film altogether. Wait, that's not even Mars.
Anyway. But do you want to talk about the actual science on Mars?
We'll get to The Martian. How about at the end? We'll save your opinion for the end of the show. But liquid water has been found on Mars.
So this week, NASA, along with the sort of had a big press release and teased us for a couple of days. They said, "Hey, they made an announcement of an announcement," which I think people were a bit worried because the other times they've done this was for the fossils in the meteorites, which turned out to be bunk, and the
arsenic-based life.
Yeah.
Which turned out to be bunk.
Yes. I was so sad about that. That was so exciting. Anyway. It was. And the sad thing behind that was a postdoc's work that she kind of pushed it a bit far and got a bit decimated. And anyway.
But there is a lot of crying wolf when it comes to NASA and press release. They just don't seem to manage this well. Every time there's a big announcement, it's preceded by so much build-up that it's not going to meet that expectation until we do find life.
Yeah.
In which case, we're all going to be going, yeah, okay, good one. What is it, life? Yeah, we found life. Yeah, come on. What? Oh, you really have?
I think even when people do declare they've seen life, it's like people are going to jump the gun a bit. They're going to see the tiniest signal and they're going to push it. And then people might tear it apart. And it might be right, but I don't think it will be. I mean, this barring a little alien coming up to the camera and waving, "Hello, where have you guys been?" I think it's enough. However, so what NASA announced today was the latest in the saga of water on Mars. It was big news because before, though water on Mars itself is not, in terms of the water molecule on Mars, is not particularly big news. We know it is in the rocks. We know it is frozen in the caps. This is the first time that we have significant evidence for liquid water on the surface of Mars, which is quite a big thing.
But why is that a big thing? Because the problem is that it would sublimate, isn't it? That there's the radiation and the low pressure means liquid water can't survive, in theory at least, until now.
Yes.
On the surface.
Well, yeah, it's thought that it's underneath, sort of flowing underneath the dunes. So this is it's a combined observation. So it was an observation both from two instruments on the Mars Reconnaissance Orbiter. So one is the HiRISE instrument, which is the high resolution camera, basically, which I was actually quite amazed to see. It can resolve things on the surface of Mars down to 25 centimeters.
Cool.
That is pretty friggin' high, right?
That is high. I was amazed by that. So that's why, if you ever have a bored weekend, I really recommend you going to the HiRISE website. They've translated it in every language imaginable, including Icelandic, and it's just amazing.
So they could find an Ugg boot.
They could find an Ugg boot on Mars. That's a really good way.
Why an Ugg boot?
Yeah, it's about 25 centimeters.
I was going to say a thong, but then I thought we might be American.
You might get me. I know I've got permanent residency of Australia now, and I've been told that means I've got to start calling flip-flops thongs.
Absolutely. Yes. That's a rule.
HiRISE had identified these objects known as reoccurring slope lineae, and it's actually a relatively old observation. They're quite small. They're about 5 meters, all the way down to this 25 centimeters, and they're like what they think of sort of runoff things that are seasonal. They think they only occur when the temperature of the surface gets up to nearly 250 Kelvin. So what's that in real money? Around minus 25 degrees C. So knowing that they had those, they've put another instrument, the Compact Reconnaissance Imaging Spectrometer for Mars, or CRISPM. I love the NASA acronyms, which is an infrared spectrometer. So it just looks at the light reflected off of Mars, just sunlight, and it spreads it out in a wavelength around 0.4 to around 4 microns of. And there's a few sort of very characteristic shapes for hydrated salts. Now, the difficulty is that CRISPM has a resolution of around 18 meters per pixel, and the smallest and the biggest of these features are about 5 meters. So there's still perhaps room for a little bit of interpretation. But looking at the data, which I'm looking at it right in front of me, it seems pretty clear that there's a signal there, very like sort of a salty liquid, which is what they're claiming this liquid is.
And this is on the surface then, flowing on the surface? Sort of
just underneath, but as you say, it would sublimate. So the idea is that it's very, very cold, but the salt in the solution is, you have this freezing point depression, which is why you can cool down your beer very quickly with a salty water bath. 3 cups of salt in a bucket of water with a lot of ice gets down to about -10, and that's the quickest way to cool down your beer.
Oh, you're right, though. It is also the coolest way. That's very cool.
And so this takes advantage of the whole freezing point depression, that you've got the salt dissolved in the water and it just stops the ice from freezing. So that's exactly what's happening, they think, on Mars, and that's enabling liquids to flow transitly, as I say, until they sublimate across the surface. The reason it's exciting is that, as I say, water on Mars, in terms of old water and water trapped on the rocks, is kind of an old story. But in terms of the idea of actually fluvial water processes going on a planet other than Earth, in a rocky planet, this is definitely a first.
And it's really cool because obviously wherever we find water, NASA immediately assumes that there's life there. And that's still a possibility, even though these are transient. When you look at things like tardigrades or water bears, they can be dried out.
Yep. And
then a few days later you add water to them and they come back to life again. They go into a sort of suspended animation. So there is a possibility, I guess.
Did we all keep sea monkeys?
No.
Yeah.
No.
Oh,
Yeah.
you put them in a tank and they came alive.
Yeah.
Yeah. Okay. Lucas knows what I'm talking about.
Yeah, my kids had those. They bought them in packets, so they're like dust.
Yeah, they're like dust.
Yeah,
and you add water and they come alive.
Yeah.
I'll be Googling that after the show.
Yeah, so like as you say, there's all these possibilities in terms of extremophiles. We're sort of just understanding a bit more now what the extremes of bacteria live in Earth, and like you have ones that are called thermophiles because they can live in really hot, piezophiles who can live in very pressured, haliophiles who can live in very salty conditions. So now I think all the people researching haliophiles will be going,
They're technically not bacteria, but anyway.
Yeah. Oh, sorry.
Technically, doesn't matter.
Okay, I'm sorry.
Anyway, that's just...
There are extremophiles. Which
I thought a very interesting aside was a story that I read on the ABC that talked about how that now they've found water, or at least liquid evidence for liquid water on the surface of Mars. They have got to be a bit careful about what they do with Curiosity. They didn't clean Curiosity enough, so
whose job was that?
Yeah, it's too dirty to go near the water because the idea is it's still got earth bugs on it.
Is there not some sort of a tree that people signed, that countries in the 60s signed, that said that you can't go anywhere near a body of water on another planet unless you're entirely sure that you're sterile or something like that? Is that?
That's what NASA's adhering to.
Yeah.
But that just shows you how careful they are, because, I mean, we've talked before about the whole building of a Curiosity rover is done in a sterile, clean room. Then it's irradiated to kill any remaining bugs. But obviously, we've talked about some bacteria that developed a resistance to that treatment process and were found in the clean room sometime afterwards. And obviously, they're worried that this might have happened to the rovers.
Yeah, I think they just didn't go through as much processes as they're already designing protocol to potentially go to Europa. And, they're realising, as I say, that what they're doing, what they did to Curiosity was nowhere near adequate. So
just going back to the water for a second. Obviously, we've seen these... these streams of what was theorised to be water going right back to, like, I think it was 2011 when these were first spotted by HiRISE, and obviously people started thinking, okay, what could cause these things? Because they appear to only occur on craters that are facing towards the sun, and that appears to be during the summer months, and it appears to be at the equatorial sort of latitudes. So, everything pointed towards it being something related to heat and heating up. And the most obvious thing was that it was some sort of melting of something that was occurring. So what's actually what has this most recent finding been? Is it just the salts? Is that what's actually?
So what they've done is they've trained this. They've analysed the CRISPR data, the spectroscopy of those RSLs. And from I should have said from the spectroscopy, you get an idea of the chemistry and what the spectroscopy. I suppose the thing is, you read the paper, and you're like, why haven't we done this before? But because, as I say, the spectroscopy data's, I think they just have been targeting lots of RSLs, I would imagine, and this is the first one where they've actually seen a good signal that's enough to publish. So 2007 was when the paper that first said about these recurring lineae, and probably since 2007 they have been using this spectrometer to try and find this sort of signal, which this is me being highly subjective, but maybe, because it shows you we're right at the detection limits. These things are very tiny. The other problem is that, they're around 5 meters, right? But the spectrometer's footprint is 18 meters. So you've got to be very sure that your signal, it would be a very weak signal anyway, because it'd be less than half the area of your spectra spot. So this is the first time that they've had a strong enough signal to go, yes, that's a hydrated liquid.
So the other thing that was very interesting to me was the process that's been theorised here. That where does this water come from? Because obviously one of the things that we expect to see, and we do in fact see, is there are ice at the higher latitudes towards the poles, where you would expect ice to form, but towards the equatorial region we don't see that ice, and in fact you would expect that ice to have long ago balled off, melted and balled off or whatever. But in this case, for this these RSLs to be occurring and flowing down these slopes, it certainly indicates that there's moisture evident in the soil, in the regolith at the top of these slopes, and for that to be occurring, the suggestion is that it's being absorbed from the atmosphere.
There's actually two theories. One is that it's sort of being condensed from the atmosphere. The other one, the other hypothesis, reading straight from the paper, is that there's a seasonal discharge of a local aquifer.
Oh, I haven't read about that one.
Yeah, in the paper they're saying that there could, as you say, there could be a spring, Martian mineral water.
That would be so cool.
Yeah, I mean, it does mean that fits with the data that they're seeing.
Wow. How long do these streaks last for, do we know? Are these like an hour or so, or just
It must be more
days?
than an hour for high-rise to pick up on them, because it doesn't go round very often.
So like a mini sort of creek?
Yes,
kind of thing.
I would imagine so. Sort of, I would imagine on the timescale of a day or a week, but I'm, as I say, making that up at this point. I mean, the nice thing is that you see the high-rise images that they change. So, you know, I don't quite know how often it takes pictures, but I would have said it probably only gets around on a sort of day type timescale.
This is just building a stronger and stronger case to send another probe there. We've got another mission in 2020, is it?
Yes.
But that's not going to be, I assume, of a higher grade enough of cleanliness point of view to not contaminate it.
It's almost a copy of Curiosity with no diffractometer. They have other instruments, but no diffractometer.
Right. Okay.
I'm not quite sure. I assume they're going to improve the wheels.
I was about to say, surely Mark II is just going to have better wheels, so they don't start falling off and it's got to drive backwards.
Yeah.
So, Penny, do you want to tell us how climate change is affecting the long-tongued bumblebees?
Of Colorado. Yes, I would. So I was like, oh, yeah, here's another story about a trait being naturally selected for, blah, blah, blah. And then when I read it, it actually really got me thinking like, from my perspective, my anthropocentric whatever perspective, is this a good thing or a bad thing? So first of all, what's happening? And the research that was done on bumblebee species living in Colorado's Rocky Mountains, and by looking at bees that from the 60s or 40 years ago that have been stored at the museums, the researchers were able to measure their tongue length. And what they found is that the tongues of two of the species living in that area have shrunk by almost 25%. And this is quite interesting because the conclusion is that this is because of global warming. The area that the bees live in is an alpine area. It's sort of classified as alpine desert, which means it's very, very dry. And it has a lot of wildflowers. So some of these flowers are long tubular flowers. Some of them are short flowers. And bees that have long tongues can drink from the long flowers, but they have trouble drinking from the shorter flowers. Bees that have short tongues are able to drink from these shorter towers. And what seems to have been happening is that global warming has changed the size of the tongue, but not the size of the bee. So something's happening with the bee's diet. And this is because of what's happening with the flowers. So because the mountains aren't cooling as much, the soil isn't getting as dry, and it's reducing the number of flowers. And that means that there's less flowers to eat for the bees. And if a bee is one that's like only eats one particular flower in a really mutualistic relationship, then there's less of that flower to eat. So bees that are more versatile are better able to survive. So in a way, this is really exciting for the bees. Like often we hear about what danger bumblebees are in and how that's going to have dire consequences for us. But here's an example of bees adapting. And the shrinking of the tongues means that they're able to feed from more flowers, the non-tubular flowers. So because there's fewer flowers overall, it's to be able to drink from as many of them as possible. But that's also quite depressing for the long tubular flowers because it means the bees can't then pollinate them. So they're on a bit of a downward spiral. And I guess the knock-on effects of this are in some ways unpredictable over the next few hundred years if global warming continues, because who knows what the flowers will affect and what the bees will affect and everything else.
Yeah.
So even though I was happy for the bees, they're adapting to changing conditions. It's kind of scary to think something this small, like the length of a bumblebee's tongue.
I just like that they've actually measuring and comparing the length of the tongues of bees. It's obviously it's a.
Still, damn it.
Well, I can imagine it wasn't particularly fun to do, especially with.
Oh, they kept on getting stung.
Well, no, but even with crusty old museum specimens, I doubt the bees just handily had their tongues extended out straight for easy measuring.
Say ah. But yeah, it's always concerning when you read that there's yet more adaptations that we're causing, essentially, through climate change. But also it's the rate that's the uneven rate of adaptation. The flowers are not shrinking in fast enough compared to the tongues of the bees and that sort of thing.
It's racing ahead and it's out of sync.
Shane, we've talked before about being exposed during the birthing process and the first few months of a baby's life being crucial to developing its immune system, its gut flora and things like that. But now there are 4 key bacteria that have been identified as being important to not developing asthma. Is that right?
Yeah, this is from a study the study was called the Canadian Healthy Infant Longitudinal Development Study, and the acronym is CHILD.
Oh, how cute.
Yeah.
NASA was involved with that, I guess.
I'm sure they were. And so they looked at 319 infants over quite a long period of time, from the ages of 1 to 5, and they basically sorted through their poo. So would have loved this study, really. Basically, yeah. They took stool samples from these infants at these different years, and they looked at what their flora was, what the bacteria were that were in the stool samples, and also how prone they were to developing asthma. And they found a few things. One, they found that, there were 4 bacteria that seemed to be indicated if you had these 4 bacteria, which they're all gut bacteria, and some of them are quite close. Well, 3 of them are more closely related than one of them, which sort of, I'm not sure if there's a significance in that, but or if there is any significance in them all being together. But it seems to be that if you've got these 4 bacteria in your system, you are less likely to show asthma. What's interesting is that also these bacteria seem to be, eventually things normalize. So in the first 100 days of life, it's all in flux. But after this, every baby, whether they're asthmatic or not, everything seems to sort of go back to normal, and you do develop levels of these bacteria. So it seems to be that the first 100 days are quite crucial to your adoption of asthma or not.
Wow.
Yeah. What they also did was they took it a bit further, and they did a mouse model study, and they basically took feces from any infant that was basically susceptible to asthma, and they inoculated germ-free mice with this fecal slurry, and as a
sorry, that's a phrase I never want to hear again. A fecal slurry.
I read the paper.
Sounds like a crap band name.
Yeah.
Sure there is a band.
We are fecal slurry.
In fact, I'll look it up. I'm sure there is one. Anyway,
no.
So some of the mice just had the background, if you like, and the other mice had the background plus an artificial mixture of the 4 bacteria, which they didn't actually get the actual bacteria from guts. They got type specimens from culture collections, so things that were relatively closely related.
Okay.
And they found that it's the mice that didn't receive these 4 bacteria also developed asthmatic-like symptoms.
Wow.
So there seems to be sort of a biological, a physiological kind of something you can replicate in an animal model anyway. So, yeah.
This is just a correlation. We don't have any idea as to the physiology behind this, though.
Of course not. It's gut bacteria. Seriously.
Well, I can't think of any way that something in the gut is going to affect your asthma and your respiratory system in that, except we do know that it plays an important part in our immune system generally. We know that our stomachs are kind of a secondary brain in that they are sending signals to determine our moods and our thought patterns and things like that. It's interesting.
It's fascinating. It's another indication that gut bacteria really are quite well. They're not just important; they are essential.
They really are essential. Without them, you're starved.
Yeah, and what's interesting is that this is also played into the hygiene hypothesis of things, that we're way too clean for our own goods, for our own good, and that generally, if you bring up your baby in an environment that's sterile, it's more likely to pick up things like asthma. Yeah. And it's quite possible that some of these babies were, brought up in places where, you're wiping down every single surface with Pinoclean or whatever to try to get rid of every single bug in the place. And,
Yeah, very cool. What would you think is the next stage in this? Is there anything more that we can gain from this? We try and introduce it to people?
Yes. I mean, look, the researchers have all said, look, this is just a proof of concept thing. We're not going to start grinding these bacteria up into pills and saying, here, give this to your infants. It's interesting. The problem is that, you also have to overcome things like what's already colonized a gut. So just giving these bacteria to infants with asthma might not actually do anything. I mean, it works in mice, but that might just be a dosage thing, because the dosage requirements are very, very different. It could be a lot more complicated than that in humans, and I guess it would be. So who knows? But it's just another sort of, it's another piece of evidence, essentially, that there are certain bugs that are important. What I would find interesting is if this is a Canadian study. They're actually repeating this study across the world with different kids, and I'd like to see if this actually holds, if the same species are involved, or if it's more of a regional thing. I mean, I can't imagine how it would be, and I'm not really sure where these kids
diets change a lot throughout the world.
Isn't there difference in gut bacteria depending on where you are in the world and what you eat and your diet?
For example, like an Asian diet might have very different microbes given the lactose intolerance thing and just their general cultural approach to food.
Well, I'd also be interested in knowing if it is a cultural thing. I mean, I don't even know where these kids in this Canadian study, where they all came from. Were they all from the same city, for example, or were they from different provinces?
Yeah.
Yeah, that would be interesting.
And even then, there's the time limit thing. I mean, in 20 years' time, how many of these babies will still have asthma or something like that? Is it something that they can grow out of or adjust to over time?
Yeah.
Damn science, making us ask more questions the more we know.
When I read this, so I asked, because my wife has sort of very, very low-grade asthma, and I asked her, when did you get it? And it got me thinking of how the severity of asthma might be. Your severity of your asthma, how would that correlate with these bacteria? If you have two of them, would you have worse or better? I don't know.
Well, even asthma itself is a really complicated topic, because it's now, I think, scientists are more starting to see it as a symptom rather than the illness itself. And so it's a respiratory condition brought on by lots of different factors. So really interesting. Let's see what they can find out next. But Lucas, we all know 65 million years ago, asteroid hit the Earth, wiped out the dinosaurs. There's growing evidence that it could have been a double whammy, that it was volcanoes as well as the asteroids. Is that right?
Yeah, there's been debate for years over what really dealt the death blow to the dinosaurs, because we know volcanism has been occurring at many stages throughout the Earth's history, and there's a lot of what we know about what took out the dinosaurs is taken from the study of the KT boundary in geology. You look at this very defined a gap or a layer, if you like, of sediment that's more or less right across the globe, which indicates that something that caused a huge amount of ash and a whole lot of material to be put up into the atmosphere then settled right across the globe. So until that Chicxulub impact crater was discovered, and it really wasn't that long ago that they drew the links to that, because a lot of it's underwater now, so it wasn't really obvious that it was a massive impact crater. The leading theory really was that it was volcanism that had done it, among some other more local things. But what this team have done, this new team out of University of California have done, is they've found they've used a technique to date a particular set of eruptions that were known as the Deccan eruptions, which started around 173-ish thousand years before the asteroid hit. So, not necessarily caused by the asteroid, but then continued for at least sort of 500,000 years after the impact. They used a dating technique which is now gone off my screen. Argon-Argon. Sorry, Argon. Yeah, Argon-Argon radioactive dating.
Okay.
It sounds a little bit double.
It's a bit Jar Jar Binks.
It is.
Oh.
Sorry. We do not mention Jar Jar
So
Binks.
this particular technique's allowed them to narrow it down a little bit more. But what's really interesting though is the eruptions that were pumping out something like 50,000. About 400 million cubic meters of lava each year. Not long after the impact, and we're talking not long in geologic terms, which is about 50,000 years after the impact, asteroid impact, or up to 50,000 years. They then started pumping out lava at a rate of about 900 million cubic meters per year. Now, that's more than double what they had been chugging along for quite some time before the impact. So it's possible that the impact actually caused some, event, and they've proposed that maybe the impact sort of made its way by some processes through the tectonic plates, because India's on the other side of the world of where the impact actually occurred, which may have then had effects on the size of the chamber that was pumping out all this lava and so forth. But regardless of that fact, whether the two things are linked or not, the fact that they've occurred so close together and very, very close after the impact, the lava spewing out more than doubled, definitely would have had an impact on life around the world. And we find that prior to the impact, there was no evidence, for example, of the foundation of the food chain collapsing. There was, for example, the various what are they called? Plankton, the phytoplankton that are sort of the base of the food chain in the oceans hadn't shown any evidence of massive die-offs until the impact. But then after the impact, they did. But what's really, really hard to tease out is, well, what effect was the volcanoes having before the impact versus after the impact? Did the increase in volcanism have a huge impact or not? Because we've just got this great big KT boundary where it's all kind of mixed in together. And one of the articles sort of pointed this out, that sort of ironically, the fact that they've closely dated these two events now may have actually just made it a whole lot harder for us to figure out how much was to do with the volcanoes and how much to do with the impactor. So
I was going to say, it's worth saying that the Deccan traps are they're one of the biggest lava volcanic events that are preserved on the Earth. They're amazing. They come up lots in geology and geosciences. And the theory that it's linked with the Chicxulub impact crater is not particularly new. It's been floated around for a bit, but this is the first sort of evidence that sort of ties them together quite nicely, or a little bit better than they were. Yeah, I think everyone for a long time have gone, it's about the same time as that big asteroid bit.
Exactly, and I think that's what this study really has brought to the table here was tying together with much more accurate dating, because they knew there was very likely that this volcanism event spanned that period of time when
as you rightfully said, before they found the Chicxulub impact crater, these guys, the Deccan traps, was the main blame on a scapegoat for the dinosaurs.
Scapegoat.
And then it kind of got its thunder stolen. Is that the best term? By the impact. And now we're back to, which is probably the more sensible thing. Hey, why not a bit of both?
Yeah. So I think for me, reading these articles and the other supporting material was, it seemed clear to me that thinking is that both these things had an impact, so to speak, on on this massive die-out event that occurred. Over 3/4 of life on Earth died out, but whether they were causally linked or whether the increase in volcanism was linked to the impactor or not, it doesn't really matter. The fact that they both occurred over a similar period of time really made it hard for life.
Yeah.
It doesn't.
I was just going to say one fun fact I've got here is that the Deccan Traps, in terms of the lava flow, is about, and this is American Center, the size of the states of Washington and Oregon combined. So it's a big area. It's a big area.
Do you happen to know off the top of your head how that compares with the Siberian Traps one? Because I know that was huge as well. And
it's definitely up there in terms of it's usually touted as. The problem is that we don't know how much of it's eroded away for sure, but it's touted to that and the Siberian as one of the biggest ones. Oh, here's another good comparison. So it's estimated, as you said, about 400 million cubic kilometers of. Hang on. Yeah,
that's it.
Of stuff. And they reckon Mount St. Helens, so you've all seen the volcanoes of that blowing up, that was 1 cubic kilometre of volcanic material. So just to get an idea of how big, and as you rightly said, with that and an impact crater, the dinosaurs probably went, we might
Oh, they definitely would have had a moment of, oh, come on!
What, massive asteroid wasn't enough? You got to do this?
Well, it's probably the other way around. It was like, all this volcanism for hundreds of thousands of years.
Just when you start getting used to it.
Yeah. Oh, look, bugger it, turn it up to max. Let's just get this volcanism happening. I've actually got, you mentioned Mount St. Helens, I've got a container of ash from Mount St. Helens. Which my kids have generally refused to be astounded by. It's disappointing.
I want to put it on my diffractometer and see if it's any different from the Iceland stuff.
Oh, I'll get you some. Yeah.
Next time I'm down at Synchrotron, I'll ask you for a bit and I'll stick it
away. Cool.
Lucas, you're now going to be co-author on a paper. This is very cool.
As one line, ash supplied by Lucas.
Cool. Even though, as you say, it doesn't really matter whether or not the asteroid and the volcanoes are linked, I'd be fascinated to learn if there was some kind of a link, whether it was, I don't know, like pressure waves through the mantle or something. But
the thing is, and you're right, because in terms of geologic scales, what they've done is they put a period of time on it. Obviously, they can't narrow it down to this particular, exact moment. But that's a period of time that's really close in geologic, terms. So it seems very likely that there's at least some interaction or some causal link between the increase in volume. But who knows? But they're so close together. It's you got to put your money on it.
Well, Bill Nye, the science guy, is often saying that the dinosaurs went extinct because they didn't have a space program. Maybe he'll have to stop saying that now. Maybe the volcanoes are just as much to blame. But, Helen, we touched on it at the start of the show. Without giving away any spoilers, what did you think of The Martian?
I really loved it.
Yeah,
I think...
had you read the book?
I had read the book.
Right.
And you should read the book.
Okay.
There are bits in the book that aren't replicated in the film, but the film is pretty faithful to the narrative of the book. It's I think I loved the most about the film. And you could be really nitpicky about the science, you could the whole dust storm. All right, so I probably should explain the premise of the whole film is that there's a mission to Mars. It's actually the third one of human missions to Mars, and something goes wrong, and there are a crew of 6. 5 of them take off and leave one guy behind. And the movie is about trying to get him back. And there's people can be nitpicky that whether there would the dust storms that causes them to abort the mission would be strong enough. Probably the case. There's all the issues about radiation wise. Would people actually just die? They'd all have cancer because it'd just be horrible radiation because there's no there's only a small magnetic field on Mars. So there's all sorts of people. You can sit there and nitpick, or you can just go, hang on, this is good entertainment. And I went for that.
Yes.
it turns out that the one good thing to come out of Prometheus, which was an awful movie by Ridley Scott, so this is Ridley Scott's next movie, was that I don't know if you remember, if you were unfortunate to watch Prometheus, the nice thing about it was the landscapes. It really sort of set you in, he put you on that other planet and then totally wasted your time. At least on The Martian, he puts you on Mars. They've obviously done a lot. I mean, as I say, I mentioned earlier on that they've obviously tied a lot with NASA for this, but they really have made the Martian landscape look good and look beautiful, as I really am sure it will be when I get there.
Yeah. So it's more realistic than Total Recall. Is that what you're saying?
Oh, absolutely. Absolutely. Because he's got the vast, and I watched it in 3D, and I would recommend, actually, I don't usually love films in 3D, but I would recommend seeing this one in 3D. It was really good, and that worked really well with the landscape of Mars, because there is quite a lot of vertical exaggeration on Mars. It's often quoted that the biggest mountain or volcano in the solar system is on Mars, Olympus Mons. Although I said that on Twitter, and a NASA scientist went, "There's a bigger one on Vesta." So looks like Vesta is a bit, but then Vesta's not quite spherical, so I think it's cheating. But.
We'll let you guys split those hairs over a few pints later on. But
but the point is, the rest of the solar system is, well, a lot of the other solar system is quite flat. Yep. Mars has some brilliant, it's got like the Valles Marinaris, this massive rift zone that's pretty much as big as the Rift Valley on Earth. So it would have those landscapes. And it was, from my point of view, just wonderful to see them in a cinematic view. I suppose that's the real advantage that it had over the book.
Excellent. So we should all go out and see it. Lucas, you'd agree that it's a brilliant film?
Yes, I really enjoyed it very much. A lot of fun, and I sat there waiting to be disappointed with the science. And there are only a few things that sort of seemed to me to be a little bit off the mark, but it was it was a case of, well, you couldn't have done it without it. I mean, for example, the force of the winds with oh no, I can't, no spoilers, sorry.
Yep.
But yeah, there were a few things to do with the size of the storm, not the size, but the ferocity of the storm, which maybe were a little bit off the mark, but it needed to happen for the whole story. So there's got to be some creative license in there.
Well, I think we need to all see it at some point and then do a spoilerific episode all about it. That sounds like fun.
Yeah.
All right. Well, that's our show. As usual, all the links are on the web at scienceontop.com/202. And you can leave a comment there or send us an email, feedback@scienceontop.com. And, of course, we're all over Twitter and Facebook. Dr. Helen Maynard-Casely, thank you so much for joining us again.
My pleasure. Thank you very much.
Is there anything you want to plug?
No, I'm pretty good.
All right. Follow her at theconversation.com for more movie reviews and interesting science articles.
Yeah, then they could send me to more movies. That was
It's a tough job, but someone's got to do it. And, of course, thank you, Penny, Shane and Lucas.
No worries.
Thank you.
Always a pleasure.
And thank you, everyone, for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
Yes, I'm delighted to say I'm joined by Matt Damon and Jessica Chastain, the stars of this film. Lovely to see you both.
Hi.
Now, NASA has supported this film, so presumably, Matt, the science is pretty accurate.
Yeah, and it is. It's kind of a love letter to NASA. I mean, and we all, I think, came away from the experience really humbled by what those guys do and the sacrifices they make. And it's hard to tell this story and not come away feeling that, I think.
And Jessica, you're so immersed in space doing this. You've met astronauts. You've done so much research. Has it convinced you that space travel is an important thing that governments should be spending money on?
Absolutely. Right now, only half a penny of every American tax dollar goes to NASA. I think it's really underfunded, and especially with, they're thinking of wanting to send people to Mars in 2023. We got to fund that. This is our generation space race, and it's a really exciting time. We're going to see people on Mars in the immediate future. So for me, yes, I'm very passionate about it. I think NASA should be funded, and so we can really explore this.
You're the space poster girl. They're very lucky.
I'm a bit of a nerd.